What's going on, guys? We have problem 74, and it has to do with derivative and limits on the to build a graph for this magnetic field. So the wire, I'm just going to give you the results, and then you have to understand the meaning behind the questions. So the x-axis carries a current, and there is a negative x direction through it. So for the first question, if you see this equation here of the following field strength, it's in between B0 x divided by length of the x-axis or the k-axis and the 0. So the first one is going to be this positive x, or the magnetic field of the x is going to be positive between 0 and L. So now we know that they are asking us to draw a graph of the magnetic field between minus 3/2 length L between x and 3/2 L. So meaning this is the negative side of x, this is minus 1/2 L, and x is in between minus 1/2 and plus 1/2 L. So to draw the graph, let's say this is 1, this is 2, so 1/2 is going to be here. This is minus 1 and minus 2, so minus 1/2 is going to be here. So the B magnetic field is moving through the x negative 1/2 and the positive 1/2, and the B, the magnetic field, is between 0 and L. So the magnetic field here is going to be between here. So this is how it looks like. It's going to come to 0, it's going to go up to L, and L is going to be like this, and it's going to go to 1/2. So this is how it looks like the graph. The second thing, they are asking us to find an expression for the net force. We know the force is equal ILB, and we know that the B is equal x over L in the x-axis or the k-axis direction. So we're going to substitute this one and put the limitation of it. So we know the I multiplied by the derivative or the direction of x on the limits between L and 0 of the magnetic field x over L. And then we're going to do, actually this thing here, it's on the negative. Let me rewrite this. So the F maximum force is going to be I on the negative x multiplied by the way, this is the limit of L and 0. B magnetic field divided by EXL. Okay, and then we're going to take out the constants. It's going to be equal to F I B O L limit between L and 0 of the x minus, or multiplied by dx, because the minus is not going to count in this limit. And then we're going to write the equation to multiply by the limitations divided by L x dx multiplied by L and 0. For the upper side is going to be equal current multiplied by the field strength multiplied by L divided by 2, because the L is going to equal 0. And this is the first function for the maximum, for the total force. Question number C. Question number C, it says, find an expression for the net torque. For the net torque, we know that the net torque in this formula is going to be equal to derivative. Well, actually, if you put the derivative torque is equal derivative of L multiply derivative of force, and if you put the torque is going to be equal the limits between 0 and L, the derivative of torque, replacing derivative of torque of the limits between L and 0, that's equal the I derivative of x multiply by the magnetic field divided by L multiplied by x. If we take out the constant, it's going to equal torque equal I B magnetic field multiply divided by L. X is going to be x squared multiplied by dx. Actually, this one is the limits between L and 0. So the torque is going to equal current multiplied by the field strength divided by L, x squared dx multiplied by L, 0. So multiplying by the upper side is going to be equal current field strength L squared, and then we're going to have divided by 3.